Hi there, Mr. Sutton with the AB Calculus 6-3 homework solutions on slope fields. For this problem, we're trying to figure out which of these differential equations matches this slope field. So I'm going to test out a few points. The first point I'm going to test out is 0, 0. That's my favorite. Looking on the slope field here, I have an actual slope of 0. Let me see which of these gives me 0 when I actually plug it in. So A and B, those are both going to be 0 over 0, which is undefined. So I can eliminate A and B. C and D both give me 0, though. So I've got A and B gone, but I need to get rid of one of these last two. So for my next point I'm testing, I'm going to test out 1, 1. That's a pretty easy one to test. Looking on my slope field here, let's see, these grid lines appear to be going by, it's like half 0.5 per grid line. So this is 1, 1 right here. That is a slope apparently of -1. It's less than 0 in any case. I don't even have to really make a commitment on what the exact number is. Taking a look here, if I plug in 1 and 1, 1 times 1 is going to give me a positive number for choice C and a negative number for choice D. So this is a no-brainer. C is gone because it's positive, and D is the answer. For this problem, g is some function such that g of y is greater than 0 for all y values. Based on that, we want to know which of these could be the slope field for this differential equation. So this is kind of like matching, but this time we've got 4 different slope fields and we have to match them to a single equation. Usually it's the other way around. I'm going to approach it the same way though. I'm going to plug something into the actual differential equation where I know this is the answer that I want, and then I'm going to see what matches up in these slope fields. So I'm going to start by testing out 0, 0. That's as easy as it gets to test. I know that g of y is always going to be positive no matter what. Over here, though, if I plug 0 in for x, then this comes out negative. So I have a negative times a positive, which is going to be less than 0. How much less than 0? I don't know, because we have no idea what the g function actually does other than it's always positive. But let's take a look at our answer choices and see which ones are less than 0 and not less than 0 for slopes at 0, 0. So choice A, that's a negative slope at 0, 0, so that's still in the running. Choice B is positive at 0, 0, so we can eliminate B. Choice C, negative at 0, 0. Choice D, also negative at 0, 0. But we at least crossed off B, and there's only 2 left to eliminate. All right, let me test out another one. I'm going to try out 1, 0. So if I plug 1 in for x, that zeroes out this parentheses, zeroing out the entire derivative, which gives us 0 for the slope. Let's see what we have that gives us a 0 slope for these answer choices. For choice A at 1, 0, we have a 0 slope. For choice C, this is a negative slope at 0, 0, so we can eliminate C. Choice D is a 0 there, so we can't eliminate D just yet. All right, so it's down to A and D. Now, if you look at these two, we can actually start comparing them. To the right of the y-axis, A and D are pretty similar. So I wouldn't bother testing anything to the right of the y-axis anymore because you're probably going to get the same thing with both of these. But to the left of the y-axis, if you compare these, they look pretty different. So let me test out a number to the left of the y-axis, like the point -1, 0. If I plug that in here, well, I'm squaring the x value, so I actually get the same thing I got for 1, 0, which is 0. And now let me compare these. For choice A at -1, 0, we do still have a slope of 0, so that matches. Choice D at -1, 0, we've got a negative slope here. So we can finally eliminate D and pick choice A. On this problem, we're trying to match this slope field with one of these differential equations. So basically, we're just going to test out a point on the slope field, see what the actual slope is, and then see which of these answer choices give us the same slope when we plug in the x and y values. So for my first point, I picked 2, -2. I often pick 0, but I kind of shied away from it on this one because I'm not really sure what 0 is. I mean, it might be DNE, it might be 0. I'm not really sure. So I'm going to pick something else. But 2, -2 down here has a slope of 0, which is easily identifiable. So let me plug in those x and y values and see what happens here. For choice A, we've got 1 plus 2, which is 3. That's not 0. Choice B, this is going to be 2 squared, still not 0, so we've eliminated 2 of them already. Choice C, we've got 2 plus -2, that is 0, so far C is still in the running. For choice D, 2 over -2 is -1, not 0. And for choice E, the ln of -2, well, that doesn't even exist. So we've actually eliminated A, B, D, and E in one shot. Wow, I'm just showing off now. So choice C for this one. For this problem, we have a slope field for a differential equation here. We want to know which of these could be the solution for the equation with an initial condition of y of 0 equals 1. So basically, we want to try to draw the curve based off of the slope field and then match it with one of these down here. So at 0, 1, we know that we're on the curve. We're just going to follow the tangent lines down both directions until we have something approaching what the curve should look like. So this is just roughly following the tangent lines, what we've got for a curve. Now, one key observation here is that this is leveling off as you approach the x-axis. And choices A and B, cosine and 1 over x squared, those actually both cross the x-axis. Cosine, we know that fluctuates between negative and positive 1. And choice B, this is an upside-down parabola, which goes down forever and starts above the x-axis at 1. Well, at least it's up there at the vertex. So we know that those can't be the answers. Choice E never touches the x-axis, so that's good. However, we know that this exponential function increases as we go to the right, whereas this function we graphed up here is decreasing. This next one, square root of 1 minus x squared, you might recognize this as a semicircle with a radius of 1, which means that this semicircle is going to stop at plus or minus 1. This graph clearly does not stop. It should look something like this and just kind of go straight down as you approach 1. So by process of elimination then, it's going to be 1 over 1 plus x squared. On this problem, I'm trying to match one of these differential equations with this slope field. Let me test out a few points on this slope field and see if I get matching results for any of these answer choices here. First one I'm going to test is 0, 3. If I look over here at 0, 3, there's nothing there. So that's dne for the slope. Plugging 0 and 3 in for x and y in our answer choices, for choice A, I'm dividing by 0, which is dne, so A is still around. For B, I'm not dividing by 0, I'm dividing by 3, so that's not going to be dne, so B gets eliminated. C, we've got 0 squared minus 3 squared, not dne. Choice D, I'm dividing by 0, so that's dne. And then choice E, we've got 0 squared plus 3 squared, not undefined. So then it looks like B, C, and E, since they did not give us undefined, are going to get eliminated. Now I have to choose between A and D. The only difference between these, A we're subtracting and D we're adding the x and y values that are squared. So I'm just going to test out the point 1, 1 here. Looking at my graph, it looks like I have 1, or not 1, 0 for that slope. So let me see which one of these gives me 0. 1 squared minus 1 squared over something that's not 1 is going to be 0. So A is still good. For D, I've got 1 squared plus 1 squared over 1. This is not going to be 0 here. So D is gone. And choice E, or not choice E, choice, what do we have? A. It's A. There we go. On this problem, I'm trying to match one of these differential equations with my slope field over here. Let me test out a few points here and see what matches over here. I'm going to first test out the point 0, 2. So in my slope field, 0, 2, right here, I don't know exactly what that slope is, but it appears to be positive. So let me see what gives me positive over here. So right here, if I plug in 0 for x, that's going to zero out everything. So definitely A can be eliminated. For choice B, we're going to have, let's see, 2 times 4 minus 2 over 4. That's at least positive, so B is still in the running. Choice C, x as 0 is going to zero out all of this stuff. So C can also be eliminated. And then for choice D, we've got 4 times 4 minus 2. That's going to be positive. So we could only eliminate A and C, but that's at least a good start. Now I'm going to pick the point 0, -1. And I mean, you can pick whatever point you want. I'm just testing another one out here. 0, -1 down here appears to also be a positive slope. So let me test that out in choices B and D now. So for B, we've got -1 times 4 minus -1. That's going to come out, let's see, a negative times a positive comes out negative. So choice B can be eliminated. And let's just double check choice D. So we've got, this is going to be positive over here. This stuff in here comes out positive as well. So choice D then works. On this problem, I'm trying to match this slope field with one of these differential equations. Now, my favorite point to test out when I'm doing this is 0, 0, but that's not really going to help us much here because it's going to give us 0 for pretty much all of these except choice E. So that would be the only one you could eliminate. So I'm going to test some other things. For example, 3, 1. So that's all the way over here. That gives us a slope over here of 0. Let's test out 3 and 1 now. So over here, I've got, let's see, 3 times 1 minus 3 is 0. So choice A works. Here we've got 3 times 1 plus 3, which is not 0, so we can eliminate B. Here I've got, this is going to be 1 minus 9, which is also not 0, so C is gone. Down here, I've got 0 times whatever is going to be 0. And we've got 0 inside here as well with that y value of 1. So in the end, only A and, no, not A, B and C. B and C could be eliminated. Let's keep going. Next, I'll test out 0, negative 1, which is a slope of 0 in our slope field here. So testing that out now in choice A, let's see, this is going to be 0 minus 0 is 0, so choice A still works. For choice D now, we're going to have, let's see, negative 1 minus 1 times 0 is going to be 0, so choice D still works. So we haven't eliminated anything yet. Choice E, however, I can only plug in a y value, negative 1, and that's not going to give me 0 in there. So we can at least eliminate choice E. So now it is finally down to A and D. Hopefully this last point will decide between these. I'm going to pick the point negative 3, 3. That's all the way up here, and I don't really know what the slope is there other than the fact that it's negative. So let's test that out in A and D. So let's see here. We've got negative 3 times 3 is negative 9. Minus 3 is, well, it's at least negative. Pretty negative, too. Choice D now, if I plug in, let's see here, we've got negative 3 getting plugged in for x, and that's being squared, so that's a positive. 3 minus 1 is a positive. D comes out positive, not negative. So D is eliminated then. And that means answer choice A is the winner. For this problem, we're just trying to graph the slope field represented by this differential equation up here. And we only have 9 points to graph. So let me make a table representing these. I need the x values negative 1, 1, and 2. We don't care about 0. And 0 for x wouldn't work anyway. It would be undefined. And we also need the y values of 0 through 2. So here's my table covering all of that. So now let me plug some things in. If I plug in, let's see here, negative 1 for x and 2 for y, that's going to be, let's see, 2 minus 1 over negative 1 squared. That's going to be just 1. And then down here, this is going to be 1 minus 1, which is 0, over something that's not 0, so that's 0. And now I've got 0 minus 1 over negative 1 squared, so that's negative 1 over 1, which is negative 1. Moving on here, now I've got, let's see here, this is going to be 2 minus 1 over positive 1 squared, which still comes out to 1. In fact, since you're squaring the x values, and since you're essentially plugging in a positive version of what you had here for x, all of these values are going to be exactly the same. Negative 1 and positive 1 give you the same thing when you square them. So I'm just going to write in 1, 0, and negative 1. Save a little time there. All right, moving on. We've now got, let's see, this is a 2 for y, so 2 minus 1 over 2 squared. This is going to be 1/4. And again, if you do a y value of 1, that's going to automatically be 0, so this whole row should be 0. Down here now we've got 0 minus 1 over 4, so that's negative 1/4. Let's go ahead and graph these. So for this first one, up here we've got a slope of 1. Next, slope of 0, slope of negative 1. And we actually have the exact same stuff in this next row here, exact same slopes. And now for this last one, we have 1/4. That should at least be less steep than your slope of 1. If you really wanted to be accurate here, you could try making a slope of 1/4 kind of by extending a line and then shortening it. So there's what 1/4 looks like roughly. Then we have 0, which is pretty easy to get, and negative 1/4 is just this flipped upside down. On this problem, we're trying to make a slope field for this differential equation. So let me set up a little table of values here. So I need x values going from -2 to 2, but I don't need 0 because there's no dots on 0. And I need y values going from -1 to +1, but not for the -2 end of things for the x values. So I've just x'd out the ones that I don't actually need. All right, let's go through now and plug some things in. So for this first one, we have, let's see, for the y values, we have 0, so 1 plus 0 over -2. That's going to be -1/2. And up here now, let's see, we have a y value of 1, so 1 plus 1 over -1 is going to be -2. Down here we've got 0 for the y value again, so that's going to be 1 over -1, which is -1. And now we've got -1 for the y value, which zeroes it out, so that zeroes out everything then. Next, for +1 for the x values, well, the only difference between this column and this column is that over here I was dividing by -1. Over here I'm dividing by +1. So really I'm going to have the same numbers over here. They're just going to have the opposite sign. So this is going to be +2, +1, and still 0. And then for this last one, we've got, let's see, 2 getting plugged in for x, and then we've got 1 plus 0 over that, so +1/2. So it looks like it's perfectly symmetrical, actually. Let's go ahead and graph these now. We have -1/2 at this point right here, and then up here we have -2. So if you kind of extend it and shorten that, there's what -2 looks like. Now we have -1, and now 0 is easier to draw than the other ones. And we actually have kind of the symmetrical version of all of these on the other side here. So this is +2, +1, still 0, and +1/2. On this problem, we've got this differential equation, and we've got this slope field. A portion of the slope field is given below. We want to sketch the solution curve through the point 0, 1. So it turns out we actually don't even really need this differential equation to do this. I'm just going to put a point at 0, 1, and now I'm just going to draw a slope field that goes through that. So I just have to follow the tangent lines going to either end of the graph. And if I do that, this is what it looks like going to the right side. Going to the left side, we're going back like this and then back up. Just follow them as closely as you can. And there we are. For this problem, we're trying to graph a slope field for this differential equation. Let me set up a table of values. And they were nice to us on this one. There's only 6 points that we have to draw slopes for. So in my table here, I'm going from just 0 to 1 for the x values, so that'll be nice. And for y values, we've got 2, 1, and -1. We don't care about 0 here. For whatever reason, they just chose to leave it out. All right, so going ahead and doing this, we have 2 times 0 minus 2 for this box right here. That's going to just be -2. And now we have 2 times 0 minus 1, which is -1. So the x value doesn't really matter for this 0 column here. And then we have -1 down here, which is +1. Next, we've got 2 times 1 for this whole column. So it's just going to be 2 minus whatever the y value is. 2 minus 2 gives us 0. 2 minus 1 is 1. 2 minus -1 is 3. Graphing these slopes, at this upper dot here, we've got a slope of -2. And now we have -1 for the next dot. This one here is going to be +1. Up here, we've got 0, which is pretty easy to draw. And now we've got 1 for this one. And down here, we have a slope of 3. Just try to make it steeper than all the other upslopes here. So something like that. And there we have it.